Let's do some more examples of 803 problems. This video will cover estimation using rectangles and trapezoid approximations. So let's start with this problem. The function f of x is continuous on the interval 2, 10. Some of its values given in the table below. Use a trapezoidal approximation with 4 trapezoids to estimate or approximate the integral from 2 to 10. So anytime you see this represents area under a curve, and we're going to use a trapezoidal approximation here. We're given some points. You have to be real careful when you're given a set of values and not the equation. You have to be very careful. You cannot use this formula. Cannot use it, because you can only use this rule when you have the function's equation and you can guarantee that all the delta x values are equal. Notice that the distance between these points are different. This one is a distance of 2, this one's a distance of 3, 2, and 1. So delta x is not the same, and we can't make any assumptions about the graph or the function, like where it is, other than those points that were given. So you can't use delta x at all. So a visual way of doing this is to just treat it like a graph and plot those points and make trapezoids. Draw vertical lines to each of those values and then connect them with slanted lines. And now you've created 1, 2, 3, 4 trapezoids. And we can just use the area of a trapezoid rule that you learned in geometry and treat them separately. So the first one is actually just a triangle where the base is 2, the height is 3. And notice the base is the distance between the x coordinates, and the height in this case is this y value. All right, the next one, however, is a trapezoid. So I know that you're used to seeing trapezoids like this in geometry. Just remember that the height is always where the right angle is. So in this case, the right angles occur down here. So this is the height. The height is the distance between the x values. In this case, it's 3 because we're going from 4 to 7 right here. And the bases are the pieces that connect the right angles. So we have 3 and 8. So this distance, these 2 points, make up this trapezoid. Next trapezoid is going to be right here. This distance is 2. We're talking about 7 to 9 now. And that height is going to be 8 and 15. I'm sorry, those bases are going to be 8 and 15. Technically, this is the height. So we've got a height of 2, which is the distance between the x-coordinates, and the bases are 8 and 15. Last one, our height is going to be 1, and it's going to be 15 and 18, the distance between these and those 2 points. And you just calculate the area separately and add them all up. Okay, let's do another one. Same function, same points. Let's use a left Riemann sum here with 4 rectangles. So again, we can't use this formula because b minus a over n, which is delta x, is unequal. They're not the same. You cannot use this formula. All delta x values must be equal. So unless you actually have the function equation and you can plug it in, then you can't do those formulas as is. You can make tweaks to them, but honestly, I think so many of us are just so visual that it's easy to just draw it. There's not that many points, 5 points. So plot those points, draw the vertical lines, and then left Riemann sum means that we're going to use A, we're going to use B, we're going to use A and A plus 1, A plus 2, A plus 3. We're not using B. This one will not give us a left because it's going to go too far. So we're going to draw our lines here, 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 and here. All right, those are our rectangles. You now just have to calculate the area of rectangles. Now this one's really not a rectangle, it's just a flat line, so it's nothing. The height is 0. The width is 2 though. This width is 3, and the height is also 3. And then this width is 2, the height is 9. I'm sorry, the height is 8. This is 1. The height is 15. So if you look at the table, it's the left one. So you're using this distance, this height, this distance, this height, this distance, this height, this distance, and this height. Because we're doing the left, we're going to be using A, like A is 2 and B is 10 here in our A and B limits of integration. So we're going to be using 0 as our first height, and we're going to use every one after it. We will not be using 18 because that's going to be what we use for the right. Okay, so we add those up. That gives us a total area of 40. Okay, let's do the same problem again. Let's use the right side. So same problem, same function, same points. We don't have the equation, so guess what? We can't use this. Again, we can't use the delta x because they're not equal. So it's the same problem. Let's just draw the graph again, plot the points, draw the lines. This time we're making right side rectangles, so we're going to be connecting this way, and this way. And we have 4 rectangles now. So now if you want to use the table, we're still using this as our width for the first one, width for the second one, width for the third one, width for the fourth one. But the fourth one, we can start at the end. This will be the height of the last rectangle. We're going to use B. We're not going to use A. So it'll be 1 times 18, 2 times 15, 3 times 8, and then 2 times 3. That's how you can cheat and use the table without drawing it. I would recommend drawing it though to start so you can get used to the pattern. But you find the area of each one separately, add them up, and you get 78. Okay, let's do one more. Same function again, same interval. We're estimating the average value of the function with the right-hand sum approximation. So we just did that and we got an area of 78. That was the last problem, the right-hand approximation. And let's look at the average value function. The average value of a function is this formula. It's 1 over b minus a times the integral from a to b. So the right-hand sum approximation we just found to be 78. That's going to equal that integral right there. So I'm going to replace that yellow rectangle with a 78. And then I'm going to multiply it by 1 over b minus a. B is 10, a is 2. And you end up with 9.75. Okay, hopefully that clears things up for you. And that's it for 803.